Hey everyone, I hope you're doing well. So I usually do introductions to my videos where I'm sat at my desk, but I'm actually on sabbatical leave from work at the moment and travelling around Europe in a camper van, so I thought I'd spare you the image of me looking slightly dishevelled. So this is the worksheet for Graphs section 7. I post all of my worksheets as well as the answer sheets on my Instagram page, so head over there if you want to see this up close and stationary. I also post about my career as well as my travels and other bits and bobs, so if you're interested in that kind of thing, then go check that out. Right, let's get into the worksheet. So what is a cubic function? It's this guy here. It looks quite similar to a quadratic function, which we looked at in Graphs section 5, except cubic functions have this extra x cubed term. Now remember that these letters here, A, B, C and D, are usually numbers. Now don't be scared by the term function. This here can still be called an equation if you want. However, because we input values of x and get out a value of y, it can also be called a function. Functions are things with inputs and outputs, like ovens. You put something in and get something out. Think of the x's here as cake mixture when you put it in the oven, and think of the y here as cake, which you get out of the oven. So what do cubic functions look like when they are plotted on a graph? They look like these guys, squiggly lines. If a cubic looks like this guy here or even this guy here, then what that means is this A term is positive. If your cubic looks something like this, i.e. a kind of mirror image of this guy, then this just means that your A term here is negative. If an examiner asks you to plot a cubic function on a graph, then all you have to do is use the skills that you've learned in Graphs section 1. That is, plug some values of x into your function and find the corresponding y value. This gives you x and y pairs which satisfy your function. These pairs can also be thought of as coordinates, which your cubic will pass through when it is plotted on a graph. So you can mark these coordinates on a graph and then join them up dot to dot style. But always remember what a function looks like, as you might not want to join the dots up by straight lines but actually curved lines like with these cubics. So let's look at a quick example here. We're told to draw the function y is equal to x cubed minus 7x plus 6 and plot it for all values of x between minus 4 and 4. So the first thing I do is draw out a table, and on the top row I list my x values that I'm going to put into the function. So here my x values go from minus 4 to 4. Then I take these x values and plug them into the function and find the corresponding y value. So let's just go over a quick example of this. Let's take x is minus 2. So if x is minus 2, what I need to do is replace every value of x in this function with minus 2. Simplify it to then get a value of y. So here we have x cubed. This would become minus 2 cubed, which is minus 2 times by minus 2 times by minus 2, which is minus 8. So this term here becomes minus 8. I then have minus 7x. So this x here I need to replace by minus 2. This term then becomes minus 7 times by minus 2, which is plus 14. So then we have y is equal to minus 8 plus 14 plus 6, which is equal to 12. So we know when x is minus 2, y is equal to 12. That is an xy pair that satisfies this function. It is also a coordinate in which this function passes through when plotted on a graph. So what we can do, we can take minus 2 and 12 and plot it as a point, and this is the point here. And we do that for every value of x, and we get all these pairs here and we plot them like these black dots are showing. This should actually be one further up here, which is the point 4 and 42, but I couldn't fit it on, so that guy is up there. And then finally you do the dot to dot step, but as you can see, if we'd have joined these dot to dot with straight lines, it probably wouldn't have looked like a cubic. Like, you wouldn't have got these arches here or troughs there. So what you have to do, you have to remember what a cubic looks like. It looks like this squiggle that goes up, down, up again, and you join these dots together. And that is an example of how you plot a cubic function on a graph. Okay, reciprocal functions. I can't even say it. Reciprocal functions sound so fancy, but they're really not. They're functions where the x term is the denominator of some fraction, i.e. it's at the bottom of a fraction. For this reason, I like to call these fractional functions, but examiners do call them reciprocal, so you should probably learn this one. There are two standard forms that reciprocal functions can come in. The first one is y is equal to a divided by x, or xy is equal to a. These are the same function, except some people prefer not to write the fraction here, i.e. they like to take this x and bring it to the other side of the equation, so they can just write xy is equal to a. So what do reciprocal functions look like when plotted on a graph? Well, they look like this or this. Why do we have two versions? Well, it all depends on whether this a here, which is usually a number, is either positive or negative. If a is positive, your reciprocal function is going to look like this guy here. So you've got lines in this quadrant and this quadrant of the graph. If your a is negative, your reciprocal function is going to look like this, where your graph is in this quadrant or this quadrant. Now, I don't know if you can see this, but these two halves are actually symmetrical, and they are symmetrical about the x equals y line. The x equals y line is a line that goes down here, diagonally down here like that. If a line was drawn there, you could place a mirror on it, and if you looked into the mirror from this direction here, you would see this exact curve, i.e. these guys are symmetrical. Another thing to note is these curves will never actually meet, and this is due to the fact that we could never have x is equal to 0 in a function like this. If you put x is equal to 0 here, the solution doesn't exist, which means these curves can't meet because we can't plot anything along this x is equal to 0 axis. Okay, let's look at an example. If you're asked to sketch a reciprocal function, you usually just find a few key coordinates that the function passes through, and then use your knowledge of what these graphs look like to fill in the rest. It's super easy, like you could get some really quick marks in an exam for a question like this. So here we have sketch the graphs y is equal to minus 2x and y is equal to 4 over x. Like I said, just find a few key coordinates that your graph will pass through. So if we look at y is equal to minus 2x first, what I tend to do is I say, well, what values of x can I take that make this fraction quite easy for me? So if I took the value of 1 here, my y would equal minus 2 divided by 1, which is minus 2. So I know if x is equal to 1, y is equal to minus 2. And I can plot that really easily. I go x equals 1, y equals minus 2 is this dot here. Now when I say values of x that are easy, an example of something that wouldn't be easy is if you chose x is equal to 3. Then you'd get y is equal to minus 2 divided by 3, which is, I don't know, what is it, like minus 0.666, which would be quite difficult to plot on here. So always choose values that are easy. So another value that I know would be easy would be x is equal to 2. That's this line here that I've written. If x is equal to 2, y is equal to minus 1, and therefore you plot this point here, and so on and so on. So here I've got 4 points that I've found. I know what reciprocal graphs look like, and so I've just sketched them roughly and made sure they pass through the points that I've plotted. Let's look at the next one. Y is equal to 4 over x. Again, let's just find the points that are easy. I've actually found that there's 6 points that are quite easy to find. We could take x is 1 and get y is 4, which is this point here. We could take x is 2 and get y is 2, this point here. Or we could take x is 4 and we get y is 1, which is this point here. And then we could repeat these x's but put negative signs in front of them, and then we would get these points here. And again, just join them up using your knowledge of what reciprocal functions look like. And voila, that's how you sketch reciprocal functions. So now is probably a good time to test your knowledge on these topics if you want. I've put some questions here. Like I said, the answers to these questions I upload on my Instagram page, so go ahead and check that out if you want to see my worked answers. I don't just give the answer, I put the workings and everything too, so hopefully this should be really easy to follow. And that's everything. Thanks for watching.